Okay, so with quadratic systems, I have a little graphic of just some things that we will see in this unit, and we'll do a lot more systems second semester, but just kind of diving into what a quadratic system looks like. When we're talking about linear systems, that was when two lines intersect. So you could have one solution, you could have no solutions, or you could have infinite. And we are going to look at when either two parabolas intersect, when a parabola and a line intersect. So we'll look at two different things, and based on the equation you can tell whether it's a parabola or it's a line, just based on the degree of the x value. So no solution would mean that they never intersect. One solution would mean that they intersect, so maybe a parabola and a line intersect at one point. Two solutions mean a parabola and a line intersect at 2 points. And then 3 and 4, we aren't going to worry about. I couldn't really find a good graphic, so we'll do this second semester, so you can just cross those out for right now. When we start doing the equations of circles and ellipses and things like that, then that'll be when all the fun starts. But for now, we're only going to look at no 1 and 2 solutions. So here's an example. Also, remember that the solution to the system is the set of points that satisfy the system. What I mean by points is you're going to get an x value and you're going to need to solve for the y value. So your answers should be in ordered pairs. Answers should be in ordered pairs. So here's an example. We have y equals x squared minus x minus 6 and y equals negative 2 plus 2x. So based on these two equations, the top one, what kind of function would that be? Would that be a parabola or a line? Parabola. I'm just going to put a p next to it. And then the second one, is that a parabola or a line? Line. You don't necessarily need to do that. It sometimes helps me to visualize what the picture is going to look like. Because x squared means it's a quadratic, and then when your degree is only 1, that means it's a line. Yeah. So most of the time, when I'm doing these equations, I use substitution, because substitution, normally they're in y equals format. So if I have y equals here, y equals here, if I use substitution, then I can just set these two equations equal to each other. And then solve. And you can solve by factoring, you can solve by completing the square, you can solve by quadratic formula. You have so many options of ways that you could solve. So if I'm going to set these equal to each other, I'm going to say that x squared minus x minus 6 equals negative 2 plus 2x. Then I want to move everything to one side, because when you're solving a quadratic, you want everything on the left. You want it to equal 0. So I'm going to add 2 minus 2x. So x squared minus 3x minus 4 equals 0. And so based off of this equation, a quadratic formula will always work. So if that's something that you want to do, then you can. And in my opinion, I always like to try factoring first. So based off of this equation, is there a way that I could factor this? You got 1 plus and 1 minus. You have different signs because the last number is a negative. So that means I've got plus and I've got minus. I need two numbers that multiply to get 4. Is it x minus 4, x plus 1? When I try it out, I do outer and inner, so negative 4 plus 1 is negative 3, so I'm good. If you did 2 and 2 and you multiplied outer and inner, it wouldn't get negative 3. Do what?
Why can you use 1 if the x is a 1? Like, aren't they not supposed to be like the same number?
Well, there's no greatest common factor when you have 1 and 1. Like, you can't pull anything out except a 1.
But everything else?
Yes. Like, if it had 2 in common, then yes, you're right. If I did 2 and 2 and I checked the outer inner, it wouldn't get -3. Okay, then I want to set each one equal to 0. So x equals -1 and x equals a +4. So those are my two solutions, but I want my answers to be in ordered pairs. So I have to take it one step further, and I have to plug in -1 and 4 into one of the originals. Either one will work. I usually choose the line because it's easier. But either one that you plug them into, you're going to get the same answer because it's a solution and that's where they intersect. So you should get the same numbers. So if I'm plugging it into the second one, -2 plus 2 times -1. -2 minus 2 gets me what? -4. So one solution is -1, 4. And then the second solution would be -2 plus 2 times 4, -2 plus 8, so 4, 6. So my final answer would be the two ordered pairs. So essentially the steps are, you get them into y equals format. They normally are already there. You set them equal to each other. You move everything over, just get it set equal to 0. Then you solve by either factoring, completing the square, or quadratic formula. Then from there, you should get your solutions. You'll either get 0, 1, or 2. Then once you get those x values as your solutions, you plug them back into an original, and you solve for the y values because you want your answers in ordered pairs. Okay, looking at number 1, doing the same thing. So my top one, what kind of function would that be, a parabola or a line? Parabola. The second one would be a line. And if you want to graph these in Desmos just to see kind of what they look like, it'll actually give you the solution, so you can check your answers that way. They're both in y equals format, so I'm going to set them both equal to 0, or set them both equal to each other. So x squared plus 3 equals 3x plus 1. I want to move everything to the left. So x squared minus 3x plus 2 equals 0. I'm going to try factoring. Since my last sign is positive, that means both of the signs are going to be the same, and they're both going to be what? Positive or negative? Negative. An x here, an x here. And factors of 2, there's only one option. 1 and 2. Set them equal to 0, so x equals 2 and x equals 1. Then I need to plug them back into an original. So my final answers would be 2, 7 and 1, 4. Okay, so when you set them equal to each other, you end up getting x squared minus 1 equals 0. You could either solve by square roots, or you could do, you can see that this is a difference of 2 squares. So it becomes x plus 1, x minus 1. When you solve them out, you get x equals -1, x equals 1. When you plug them back into an original, so y equals -3, what kind of line is that? Like if I were to graph that, what would that look like?
It would be a vertical.
Horizontal. Horizontal. So if it's a horizontal line and I'm at y equals -3 and I have two ordered pairs, then my y value is always going to be -3. So at -1, -3, and 1, -3. So that's how I got my y values from that. But even if you were to plug it into the top one as well, like let's say you got confused by the bottom one, if you plug it into the top one, you should get -3 for your y values as well. So it looks something like this. Beautiful picture. Okay, so on this one, when you move it over, you end up getting something like this where there is no c value or there's no constant. So when you have that, you actually solve by GCF, or by greatest common factor. So they both have an x in common. So when I pull out the x, I'm left with x plus 1, and that's as far as you can go. You can't factor, you can't do anything else. So when you are left with that and you're solving by greatest common factor, GCF, you set the x equal to 0, and you set the x plus 1 equal to 0. So you get two solutions. You get x equals 0, and then you get x equals -1. When I plug both of those into an original, when I plug in 0 to this equation, I end up getting 2. When I plug in -1 into this equation, I get 0. So my 2 points are 0, 2, and -1, 0. Yes?
I plugged mine into the top, and for my y I got 6, and I don't really know.
Which one?
For the -1, 6.
Whenever you squared -1, did you get +1?
Yes. Yeah, I could have put it in there.
So,
Okay, here we go.
okay. Okay, try number 4. Okay, on this one, you notice that you have like a negative x squared here. That bothers some people. Since I set it equal to 0, I can divide everything by -1. Since it has equals 0. So I could divide the left by -1, I can divide the right. It's kind of the same as like taking the entire left side and moving it over to the right side. And so when I do that, I'm just essentially flipping the sign of all of these, because 0 divided by -1 is still 0. Then I factor x plus 5x minus 1, solve x equals -5, x equals 1, plug them into this equation, and I get -5, 0, and 1, 6. So for number 6, what you will need to do is you actually need to FOIL it out. So we'll do this one together. So we have 2x minus 1 squared minus 2 equals x minus 3 squared. If I moved this over, it'd be minus 1. I'm going to FOIL everything out so that I can simplify. So when you have if they're both in vertex form, you're going to simplify, or you need to FOIL out so that then you can combine and simplify. So I'm going to write this as 2x squared minus 2x plus 1. X squared minus 6x plus 9 minus 1. I would encourage you to start getting in the habit of FOILing in one step instead of writing it out as 2. Because sometimes we tend to want to write it like this and then do x squared minus x plus 1. But we are smarter than that. We don't need this second step. We can just do it in our heads. Saves us a lot of time. This step is unnecessary. Because remember, you're doubling it and then you're multiplying the last two terms. Just a helpful hint. Then I'm going to distribute, so 2x squared minus 4x plus 2 minus 2, then x squared minus 6x plus 8, because I'm combining these. These cancel. 2x squared minus 4x equals x squared minus 6x plus 8. Then I want to move everything to one side. So x squared plus 2x minus 8 equals 0. Want to factor this? Will they have the same sign or different signs?
They will have different signs.
Different signs because of the negative 8. Multiply to get 8, add to get 2. 4 and 2. Which one needs to be the plus sign? 4, because it's positive 2. So x equals negative 4 and x equals 2. I'm going to plug them in. This is where it gets a little bit more difficult because none of these are really that nice, unfortunately. So, I don't know, let's choose this one. I'm going to come over here. So if I'm plugging in negative 4 minus 3 squared minus 1. Negative 7 squared minus 1. 49 minus 1. 48. I'm plugging in 2 minus 3 squared minus 1. Negative 1 squared minus 1. 1 minus 1 equals 0. So my two ordered pairs are negative 4, 48, and 2, 0.